Okay, so let's go over the first one. So the first one is about that cystic fibrosis caused by a recessive gene. So what's the percent chance of having children with cystic fibrosis if there's a fertilization event between a parent who has cystic fibrosis and one that is heterozygous? So if it is a recessive condition, the parent that has cystic fibrosis has what genotype? Are they going to have two big letters or two little letters? Two little letters. So little a, I'm just going to use A's. And then if the other parent is heterozygous, they're going to have a capital letter and a lowercase letter. Okay, so up on the top, we have big A, and on the bottom, little a. Okay, so what's the chance of getting a kid with cystic fibrosis? Yep, 50%. So if both parents are heterozygous, what would our chance be? Yeah, it'd be 25%. So the reason why is because when we do a Punnett square with big A, big A, I'm not going to do the whole cross, but only this one box down here would have little a. So that would be 25%. Okay. All right. So the next one, so suppose in humans that brown eyes are dominant to blue eyes. So we have a brown-eyed man and a blue-eyed female, and they have 3 children. 2 of them have brown eyes and 1 has blue eyes. So what does the man's genotype have to be in order for him to have blue-eyed kids? So we know if he has brown eyes, he has to have at least one copy of that dominant, but what does the second letter have to be? It has to be a little b. Good. Okay. So if the dad is big B, little b, the mom is little b, both of these kids are going to be like that. I'm just going to draw an arrow. And both of these kids are going to look like that. I'm just going to draw an arrow. So the genotype of the brown-eyed children has to be big B, little b. And the blue-eyed kids have to be little b. Okay, does that make sense? So can a brown-eyed parent have blue-eyed kids? Yes, they can. Okay, it's not always the milkman. All right, and then the next one. Okay, so in peas, being tall is dominant to short. So if we have a heterozygous pea plant, so big A, little a, crossed with a short plant, so that's going to be little a, what's the chance of getting short plants in the next generation? What is it? Very good. Yes, 50% chance. Because this one and this one will both be little a. That means that they're short because they have that recessive condition. Each of these are going to have that dominant trait, so they are not going to be short. All right. So for these big honkin' ones, oh, can I draw a rectangle? This is so exciting. Wow. I'm just like figuring out all these things on my computer now. Okay. So what is the first thing we need to do when figuring out these problems? Because I didn't give you letters. So what's the first thing you have to figure out? Right. Which one's dominant, which one's recessive, and just assign them random letters. Is it going to be wrong if you use a different letter? No, it's not going to be wrong if you use a different letter. It's still perfectly correct. Okay. So in llamas, floppy ears are dominant to pointy ears. So what letter do we want to use? Let's use E for ears. So floppy ears, we're going to make capital E, pointy ears, lowercase e. And buck teeth are recessive to normal teeth. So what do we want to use for teeth? T? Okay. So normal teeth are dominant, so that's going to be a capital T. And buck teeth are recessive, so that's going to be a lowercase T. can't talk. So a male llama with floppy ears. So he's heterozygous. So I'm going to put that down right here. So for ears, the male is heterozygous. And he has buck teeth. So are buck teeth dominant or recessive? They're recessive. So he's going to have 2 copies of that little T. Okay? And he's going to cross with a female llama that is heterozygous for both traits. So if we go down here and look at the genotype for the female llama, she's going to be big E, little e, big T, little t. Okay? So for this question, for B and D, what are the alleles for sperm he can produce? So he can make sperm that has the big E in it, and the little e, and the little t. Can he make big T sperm? No. What about the female? What kind of eggs can she make? She can make big E eggs. She can make little e eggs. She can make big T eggs, and she can make little t eggs. So she can make all of the different kinds of eggs. Okay? So now what's our next step? What do we have to do? Right. So we have to put the E's in one Punnett square and then just the T's in another Punnett square. Okay. So I'm just going to do that really quick. It is really, really hard to draw with my mouse. Or maybe I'm just an idiot. I don't know. Okay. And then do one for the T's. So I'll put the male on the top, female on the side. We're all pretty good with doing the actual crosses. Okay. And then over here, we have our big T and our little t. Whenever you're doing these, always try to choose a letter that's different, capital and lowercase. Otherwise, it gets really confusing. Okay. So what is the chance of getting a llama in the next generation that has pointy ears and normal teeth? So we know that pointy ears is recessive and normal teeth is dominant. So if we're looking in the ear Punnett square, what's the chance of getting pointy ears? How many are totally recessive? Right, 1 out of 4. So here we have 1 out of 4 that is completely recessive. And then over here, normal teeth is dominant. So how many are going to have normal teeth? 2 out of 4, right. Or 1/2. Okay. So what's a quarter times a half? 1 times 1 is 1. 4 times 2 is 8. So what's the chance? 1 out of 8. Okay. By raising your hands, how many of you guys got that? Awesome.